Welcome to this presentation on compacted cell culture media. Today we will present data on this new technology application that demonstrates its potential to increase the efficiency of dry powder media applications, thereby leveraging their advantages. Compaction is a granulation technology, but importantly, a dry granulation technology, where no water or other additives are added to the process. Compression force alone is used to form the compacted media. The process is controlled by the following production process parameters: the design of the compression unit, the force applied, as well as the media formulation. Compaction technology makes it possible to fix the homogeneity of fine cell culture media powder in the form of larger particles. The powder enters the process from the top and emerges at the bottom as larger particles after compression and breaking. You can see the starting powder and resulting compacted media in the photographs. In the next slides, I'd like to highlight the advantages of this technology, making dry powder cell culture media more efficient to handle. The first advantage compacted cell culture media can bring to the upstream process is easier handling of bulk material thanks to improved flowability properties. The picture of a revolution flow analysis here illustrated this effect quite nicely. The powder medium in the right-hand image has a steep angle and breaks rather than flowing like the compacted media in the left-hand image. This observation is confirmed by the measurement of break energy shown in the graph. Almost all compacted media have a break energy of around 30 kilojoules per kilogram, significantly less than the respective powders. A clear dependency on the respective media formulation can be seen. The picture of the revolution flow analysis shows Salvento CHO 210 dry powder and compacted medium. The observed difference corresponds to a decrease in break energy of 3 kilojoules per kilogram. The second advantage compacted media deliver is mitigating the dust-mediated contamination risk. These three pictures show a simple experiment. Before the flasks are shaken 3 times, you can see a clear headspace above the powder on the left-hand side and above the compacted medium on the right. After shaking, the headspace above the powder is filled with dust. Having the bottom line of the powder marked by the arrow, you can see the heavy dust formation in the headspace. By contrast, for the compacted medium, we see much clearer headspace above the bottom line of the product, indicating reduced dust formation. We have also analyzed this effect with a spectrophotometer, quantifying particles below 34 micrometers in 1 liter of air. The data shown on the graph indicates that we see a 13-fold dust reduction when comparing powder and compacted media. The third advantage compacted cell culture media can offer is increased bulk density, leading to reduced bulk volume. Taking into account that 2/3 of shipping and storage costs are related to product volume, this can significantly increase efficiency. The image here makes the effect clearly visible, with 350 grams of compacted medium in the cylinder on the left compared to 350 grams of powder medium in the cylinder on the right. The increased bulk density here is twofold. The graph shows data for several cell culture media formulations, demonstrating how this effect depends on the formulation. For most formulations, at least a 1.5-fold increase in bulk density could be reached. As the fourth and final advantage, I would like to present the improved dissolution speed that compacted media can deliver, especially for high concentrated formulations. The operation time can be reduced by 2/3, bringing clear advantages to the upstream process. In the top row, you can see what happens when a powder formulation is added to a mixing vessel at roughly 100 grams per liter. It swims on the surface for several minutes, and dissolution only takes place on the underside of the floating powder. After 22 minutes, the formulation is completely dissolved. By contrast, the compacted cell culture media formulation directly sediments to the impeller of the mixing vessel and is brought into solution much faster. After 120 seconds, the solution is already starting to become clear, and after 7 minutes, the formulation is completely dissolved. The faster dissolution speed observed in this experiment is because the water-accessible surface of the powder is much smaller than that of the compacted medium, as only the underside of the floating powder is water-accessible and not the entire formulation. If you are wondering about the residual medium on the top of the liquid, this is because the solubilization was performed in 80% of the final volume, and water addition will wash the remaining medium into the mixing vessel. Finally, I'd like to summarize all the advantages that compacted media can bring to the upstream process, leading to a more efficient application of dry powder cell culture media. Firstly, the improved flowability properties ease the handling of bulk volumes of dry powder media. Secondly, reduced dust formation leads to cleaner production areas, lowering the risk of contamination. Thirdly, compacted media lower the bulk volume of dry powder media, leading to savings in transportation and storage costs. Last but not least, compacted media can save time when it comes to dissolving highly concentrated cell culture media formulations.